The very back page. I warned you today in class, and I'm warning you again for anyone watching this. Please read the directions. Okay? Now, tomorrow I don't think I'm going to make you define two variables. We haven't really harped on that as much because that's something we really pegged earlier in the year. We were like, hey, you have to do it, you have to do it, you have to do it. Okay? You should know how to define two variables. But really what I'm really, really concerned with is just using good variables. Use descriptive variables. Okay? I mean, X and Y are fine as long as you tell me what X and Y are. Or for one like number 16, you can just use A for adult and C for children, and that tells the story on its own, okay? So again, if you would like to, whenever you go through these, use the correct variables. If you're going to use X, Y, you better name them. You better tell me what they mean. I don't want to be guessing. Got to know. Now again, the directions say set up each word problem, okay? Each meaning all four. Set them all up. That's going to be worth points on every problem. Every problem, setting it up, writing the equations correctly will probably be worth a couple points, okay? You may pick only two of the problems to completely solve. And let me reiterate that. Only two to solve. So someone, and I promise you someone's going to do it, even though I'm saying this now, someone's still going to do it. Someone's going to do all four of them. And then they're going to be mad whenever they get 16 and 17 wrong, but they get 18 and 19 right. They're going to be like, well, why didn't you just grade 18, 19? They were right. If you do any more than two, I'm only going to grade the first two done. That's it, okay? I'm not going to pick and choose your best two. You should pick and choose which two you think you can get right. And if you get stuck on one, let's say you're working 16 out and you get stuck on it, okay? Then just erase or just scratch out some of your work or just write a little note saying, don't grade this one. If you can't do one of them, just make sure you don't do it, okay? If you get stuck on one, erase it. Make sure I don't grade that one. Okay, you still need to set up all four problems, but you only work out two of them. All right? So let's talk about that setup with number 16. Miss Smith took her family and friends to the movies. There are a total of 13 people. Okay, children's tickets cost $4 and adult tickets cost $9. She spent a total of $67. How many children and adults went to the movies? So to set this up, this is two equations. The first equation is pretty easy to find for most people. Okay. Children tickets cost $4. That means 4C plus $9 for adult tickets, 9A equals $67. That's the one that most people can find immediately, okay? Now, if that's the only equation you could find, well, then obviously you're not going to get all your points for the setup. You're going to get a few, but this is not going to be a problem you work if you can't find that second equation. So just go ahead and say, well, not doing number 16, better hope 17, 18, 19 work out better. That's just test taking because I'm only going to pick two to solve. But because this is the review, I'm going to solve all of them, and I want to go ahead and point out where the second equation comes from. The second equation comes from this little tidbit right here. And we've seen one like this in your skills practice book, okay? We saw one like this. It was talking about t-shirts. Now, a total of 13 people went. That means all the children plus all the adults totaled 13 people. That's where the second equation comes from, okay? Now, let's say you figured that out and you decided this is one of the problems you're going to work out. Well, then I'm going to do this with elimination, all right? And namely, I'm going to go ahead and eliminate the C variables by multiplying my bottom equation by -4. Because I want this hidden one, to become a -4, okay? My top equation stays the same. 4C plus 9A equals 67. My bottom equation is new, however. -4C minus 4A equals -52. I'll double check myself there real quick. That was a little bit of quick math in my head, but I'm not really that great with my 13 times tables. So let's double check. -52. No harm in putting it in the calculator, okay? Whenever we add these together, my C variables are going to eliminate, and I get a positive 5A equals 15, okay? Positive 5A equals 15. Now, when I divide by 5 on both sides, I get the A equals 3. And you can really just go ahead and shortcut this and be done with the problem if you're clever and you're thinking about this in terms of the real world. Well, A equals 3. That means 3 adults went. And there were a total of only 13 people, which tells me 10 children went. You really rather write that out in a bit of a better sentence. Say 3 adults and 10 children went. You know, not 3 adults went, 10 children went, but you get the gist of it, okay? How would I do that if I wasn't thinking about it in terms of the real world? Where you take A equals 3 and you plug it into one of your original equations. I definitely wouldn't be using that top equation. It's got a bunch of numbers. You plug your 3 in here, you get C plus 3 equals 13, because I plug a 3 in. I have to subtract 3, and get, again, C equals 10, okay? So let's say you looked at number 16 tomorrow, and it won't be the same type of problem tomorrow. They're going to be shuffled. But let's say you looked at it, and you're like, hey, you know, I got the setup perfect. Might as well work this problem out. If it didn't work, if I was getting weird decimals and stuff, maybe I just draw an X through that one and say, maybe not that one. Just leave the setup, okay? Make sure whatever you do, you have that setup there. 17, okay? We're talking about a gym that offers 2 memberships. Plan A is $30 a month after a $100 registration fee. Plan B is $50 a month after a $20 registration fee, okay? So one of them has a $20 registration fee, but costs $50 a month, so it's more expensive per month, okay? But it has a cheap fee start now. This is the kind of gym a lot of people probably join whenever it's right after New Year's, and they're like, I'm gonna get back in the gym, I'm gonna lose a lot of weight. They probably join this one because they're like, oh, it's only $20 to register, but it's $50 a month. You better be going and getting your money's worth out of there. Plan A, it's $100 up front, okay? That's the gym that's kind of getting your big registration fee, but assuming you're not going to be there very long, okay? Big $100 up front, and then only $30 per month after that. So that's how these 2 equations work out, okay? Whenever I think about that, I think that we have a slope or a rate and a flat fee, okay? A rate meaning a slope, and then a flat fee is my y-intercept. We've seen this a lot of times we've seen this, okay? And if that's how both of these work out, I can just go ahead and write my 2 equations. For gym A, I have y equals the rate. The rate was $30 per month plus 100. For gym B, my y equals my rate, which was $50 a month, okay, plus a $20 registration fee. And the question asks, after how many months will a membership on both plans cost the same amount? So we want to know, how long do I need to keep going to these gyms before they're the exact same, okay? This is the problem that I can already see now a lot of people probably aren't going to do as one of their problems they work out, but you at least have to be able to try the setup. If you can get the setup right, this is a very easy problem because it's a graphing problem. We have y equals all by itself on both equations, and when that happens, that means we're going to graph it. So if you can get the setup correct, if you know the difference between a rate and a flat fee, okay, a rate being a slope and a flat fee being an intercept, a starting point, okay, then this problem becomes easy because it's just a plug and chug with the calculator problem. All right, y equals, you clear out whatever someone's left in there. This top one was 30x plus 100, that's $30 a month with a $100 fee up front. The other one was 50x plus 20. So it charges you more per month than the other one, but has a lower starting value. When we hit Zoom 6, we're actually not going to see these 2 things. Oh, you kind of do a little bit, okay? But we're going to want to Zoom 0 or just start pressing Zoom out, okay? And we see when we hit Zoom 0 that we've actually got both of these things on here, okay? We've got both of these lines on here, and we can find out where they intersect. Now, just a reminder, this is our gym that started out cheaper. It was only $20. This one was $100 to start. But look, it doesn't really take that long before all of a sudden they're worth the same. And then everything after that, this gym that you paid more for up front is going to be cheaper. So let's find that intersection. Second calc intersect, enter. And we see that it takes 4 months. That's what the x value is. This is always time. 4 months to equal the same thing, and that same point will be $220, okay? So our answer was 4,220, but if you give me this and box it in, you're gonna miss out on some credit, okay? Because that doesn't actually answer the question. The question was, after how many months will the membership plans cost the same amount? And that answer comes from our time variable.